Well, good morning, everybody. It's a Saturday morning, and we've got a birthday party today in the household. My oldest son, Peter, turned 13 this past Wednesday, but we're going to have the party today. So I don't have a lot of time this morning, but wanted to sneak down here and take a look at the motor for the Vernon Lathe. Getting real close to actually putting some power to this thing and starting to see some things spin. So this is the motor that came with the lathe. It's a good motor. It's a Baldor industrial motor, single phase 220 volt, so I don't need a phase converter. This is the motor that was on the lathe when I originally bought it, so I actually did see this motor run. Paint or whatever this coating is on it is peeling, but and it's dirty, but if I recall correctly, this actually worked pretty well. Now, interestingly enough, I just realized this motor is dual voltage, so this could be wired for 115 volt even, which is great because for my initial setup and testing, I think I'm going to run it on 120. So I'm going to clean this up on the outside a little bit, and then we'll wire it up and we'll run it and see how it sounds. I want to hear how the bearings sound. I believe this is an older motor because it's got Zerk fittings on the top, on the front end plate and the rear end plate. Both have Zerk fittings at the top, which there are little channels that look like they go right down and lubricate the bearings. There's just the slightest bit of noise there. But what troubles me right now about this thing, and I'm hoping it's just something to do with the pulley. Just reposition the camera so you can get a shot of this. But you see that pulley's got a discernible wobble to it. Now that might not seem like a big deal, but my thinking is at speed, that's going to translate to an oscillation into the belts. That's going to possibly translate into some kind of interference on the whole drivetrain, or added noise and vibration that we don't need. More than anything, I just think vibration is going to be the enemy here. So I'm hoping maybe it's just a matter of remounting that pulley. But I think what I'll do is I'll power it up with it the way it is on the bench, see how bad that vibrates, and then that way I'll know when I try and adjust the pulley whether or not I'm improving things. Oh, my LA's totally awesome. Doing a good job on this. Hey, you can even see some of the gray paint. And it looks like these end caps are aluminum. I'm not going to get too hog wild crazy about cleaning this thing. I just want to get the heavier stuff off, and some of the stuff that's peeling, I just want to kind of get that off now so it's not falling off all over the place. This is the screw for the cover here. Oh well. The only place where it's kind of flaked off and peeling is on the bottom here. Now you can see in the end plate here, this is really filthy. But I don't want to be spraying this stuff in there. Plus I wouldn't be able to really get in those nooks and crannies anyways. If I wanted to get really serious about cleaning this motor, what I would do is I would take this end cap off and I would clean it in the parts cleaner. And maybe I'll do that, but let's hear this pig run first. Oh, it's just unscrewing this. Even the gasket's in there. Corner of it's cut off for some reason, but that's nice. Alright, so disconnected this at some point, and just kind of even stuffed the wire nuts in there. And so we've got, obviously one of the lines went to there, and then Well, that's a stray. Alright, so these are all held together with one wire nut. I had the wire nuts off of this one and this one, so there's your two lines right now. So I believe he had this wired for 220. So these little tiny metal things right here are actually number tags. And it's common to see these on some of these motors, especially I think on the 3-phase. They like to use those little tags, some of them. What's nice about these is, unlike the little paper things or whatever, they don't just fall off over time. So what we've got is we've got 4 and 5 tied together, go into line, and 1 go into line by itself. So what's over here is your little chart right here, and it shows you, the lines connecting the dots mean that those are the wires that are going to be tied together. So the low voltage connections would be 1, 3, and 8 tied together, and 2, 4, and 5 tied together. So obviously we don't have that. High voltage is 3, 8, and 2 tied together, going nowhere. 4 and 5 tied together, going to line, and 1 going to line, which is what we have. So right now, this thing's wired up for high voltage. And when they say high voltage on motors, they mean the higher of the two voltages offered, which right here on the volts it says 115/230. So high voltage means the 230, low voltage means the 115. I only mention that because I'm used to, in electronics, like when we were working on television sets with CRTs, high voltage is thousands of volts. And if you talk to a lineman who works out there on the street, you ask him what high voltage is, he's going to have some other completely different answer too. So, but who cares? Oh yeah, the other thing to note about this motor is that this is a single speed motor, and the RPMs on this motor are 1725. I think this is an older motor. Nowhere near as old as like the motor that came on the Hendy, which I think is a repulsion induction motor or something like that. But anyways, should be, pretty decent choice for this lathe. If it was a single speed motor that was a high speed, then it would be probably 3450 RPM, I think, or something like that, which wouldn't be good. That'd be that much more speed going into those poor plain phosphorus bronze bearings. So getting back to this, while I work on this wiring, I think I'll mention I looked at another lathe. Yeah, I know. Yeah, popped up on Craigslist. It was only one town over. Had to go take a peek. And to keep things under control, I made an offer that was quite a bit lower than what the gentleman was asking for it. And I figured that would be my justification, that if he actually accepted the offer, I said, well, then I've got to take it home. Because it would have been, he's got my offer, but literally the night I went and looked at it, somebody else was coming over that night to look at it. And that was Thursday night. It's now Saturday. He hasn't called me back, which means either A, he sold it to the guy who came Thursday night, B, he sold it to somebody else, C, he set other people up to look at it this weekend and he wants to see what they're going to offer him, D, he doesn't like any of our offers and is going to sit on it, but I don't think that's the case, because he said he definitely wants the space because he's got another lathe coming, a larger one, because he works for a machine shop and they're retooling, so they're getting rid of their, what do they call it, Mori Seiki? I forgot. I've seen that name before though, but they're getting rid of those, so he's getting one of those. So the lathe is a, I think it's a 12-inch, Rockwell. So I did a little research, and turns out that it's kind of like the tale of two Rockwells. There's the smaller Rockwell lathe, which you don't see a lot of people say anything great about them. And then there's, I think it's a 12-inch. If wrong, I'll try and remember and edit it and put it up on the screen. But it turns out that the one he has there is the better of the Rockwells. It's actually a pretty good lathe, considered by many to be superior to a Logan or a South Bend. And those of you who are big Logan and South Bend fans, obviously, you know, you might not feel that way, but hey, it works that way with everything, right? It's like my Wells Index mill. The guy had a Bridgeport sitting there. I was telling him about my Wells Index, and he actually said, you know, the Wells is a better machine. And that's a whole nother debate. Anyways, so it's a benchtop lathe, but it's sitting on its own cabinet, and the 3-phase motor and a variable clutch mechanism for speed control that's worked by a cable and pulley system is inside the cabinet. Those were prone to being problematic. This one actually seemed to be working. I went and looked at it actually twice. I went and looked at it the first time. It was covered with grime and not hooked up. And then I said, I'd really like to hear the bearings run. So he hooked it up to his 3-phase converter about a week later, and I went back and looked at it again and heard it run. Seemed pretty good. Also verified that the back gear was working, because that's another common problem on that particular model. The back gears were prone to having teeth removed accidentally, because there's a lever on the front that has multiple positions. It's a back gear, normal gear, neutral, and lock. You can lock the spindle, which aids in taking the chucks on your chucks and everything on and off. So that lock position was, I guess people would put it in the lock position, forget that it was in the lock position, and maybe try and run the lathe, and I guess it could break teeth. The quick change gearbox, I didn't go through testing all of the ranges, again because I partly felt that he wasn't going to accept my offer anyways, and partly because I just, you know, it's not something that I need, another lathe. But the quick change gearbox, I guess there's a lot of brass gears in there, and that those can have damage. The bad thing about the Rockwell is virtually no OEM parts available any longer. The good thing about the Rockwell is there are some aftermarket parts available when needed, and most of the gears and everything and bearings, from my understanding, are kind of standard off-the-shelf type sized items, so that you can get something, like maybe from a Boston Gear Company or something like that. The other pros that it had going for it, it had the optional flame hardened bed, and for tooling, it had a 4-jaw chuck that was rusty and dirty in a box. It looked like it hadn't been used ever. Had a 3-jaw chuck that was on the machine. It had a 5C collet attachment and some collets. It wasn't the chucker collet, it was the like the Jacobs style, I forgot what they call that. The kind that you turn the outer wheel to unlock it and slap the collet in and then tighten it up. Another big plus was it had the L00, I believe, taper for the spindle nose. And I pulled that off and looked at it and examined it, and the taper was nice and clean, no damage to it. Ball bearing, spindle bearings, thing was capable of, I think, 1550 or something like that top speed, which would be, I think, 50% faster than either my Hendy or my Vernon could go. So it'd be nicer with turning carbide, with using carbide cutters. But hey, you know what? Maybe I'll get lucky and the posting's still up on Craigslist, so excuse me, he might not have sold it. And maybe the other guys lowballed him even more than I did. But my gut tells me that that thing's gone. Alright, enough about that. Let's get to wiring this thing. So I want to go for low voltage here, so I'm looking over here and don't have my reading glasses, so I'm going to verify with this magnifying glass. that we want 1, 3, and 8 tied together, and then 2, 4, and 5. So we're not going to need one of these wire nuts. So there's 8. There's 3. And there's 1. So this makes it pretty easy. 1, 3, and 8. And that should just leave 3 more, which are going to be 2, 4, and 5. Alright, what's the current draw on this pig? Oh, by the way, this is a 1.5 horsepower according to the data plate here. 10 amps on low, well, no, wait a minute, it's 20/10. I'm used to seeing the low speed, high speed amperage because I work with a lot of 2-speed motors. No, so it's going to be 10 amps on 230 volt, 20 amps on 115. As a rule of thumb, if you've got a dual voltage motor, when you're using the higher voltage, it will draw less current. That's actually one of the theories behind why it's more efficient to run the motor on the higher voltage when it's available. But I'm not a engineer. But I'll tell you what I do know. I do know that my plan to use this is not going to work. We're going to try and avoid having to hook up a ground. So I was going to use this GFI cord, which I have. This is one of my wife's hair dryers that crapped out, and you know what, this is 15 amp because of that heating element in the hair dryer. But it's got a built-in GFI, and hey, if nothing else, you cut the cord off for the copper wire. Waste not, want not. It's a $20 hair dryer probably. Went in the trash anyways. Might as well try and rescue something off of it. So let's just see what happens. Alright, so the ground wire. Well, why do I want to hook up a ground wire? Well, because the case is supposed to be grounded on the motor, if you have a problem with like insulation that's broken down and for some reason one of the windings is shorted to the case of the motor, if the motor's grounded, well, the current's going to be shorted to ground, and it's going to, you know, trip your breaker. But if it's a high resistance short, you might get enough current flow into the ground that it just draws more current overall than the motor should be using, but doesn't trip the breaker. But what will happen is, in this particular setup what I'm doing right now, if you notice now, I have no ground hooked up, so now the case is what we call floating. It's not grounded, it's floating. So if we've got a high resistance or low, any kind of a short to the case of the motor from the windings, what happens is if I touch this case and I'm grounded, I touch this case, now I'm completing the circuit, and the current's going to want to flow from the case through me, electrocute me, and go to ground. If it's a high resistance short, it might be, you know, a small enough amount of energy that I just get a little zap or feel a tingling sensation. But I'm not going to touch it to find out. Well, at least I wouldn't touch it if it was not wired to this, which is a GFI. So what the GFI does is, this is a special circuit inside here that monitors the flow of the current through the circuit. And it's looking for all the current that's going out and doing the work in the circuit to come back through the circuit. And if any of that current is coming back through the circuit, if any of that current is going through a short to ground, this will notice the imbalance and will trip the circuit and shut it off. This might trip like a son of a gun because it's only a 15 amp and the motor might not like that. Oh, I misspoke. It's not the motor that wouldn't like it. The GFI might not like it, especially on startup. On startup, there's an instantaneous, momentary high current draw that's followed by when it settles down. Yeah, there's no load. So that 20 amps, that's going to be under load. Well, I'll tell you what. I don't even know if I want to mess with that pulley at all. Oh, I probably should have tested my GFI before I touched that. Press this test button and my GFI trips. If you have any GFIs around the house, it's a good idea to occasionally press the test button, and if it doesn't trip the GFI when you press the test button, it means the GFI is bad and should be replaced. It means it's no longer protecting you from electric shock, even though the way they're designed, they'll still pass current. So the manufacturers rely on you using that test button, which not enough people do, especially if it's a 220 volt GFI providing power to your hot tub. People don't think to go over and test that one, but there's a good sized test button on most of those. Depending on the manufacturer, it's usually a big white button that says test on it, or it's a smaller button but it's yellow to stick out against the black background, and that's what it's there for. Test them, guys. You might save someone's life. Serviced a hot tub just this past week. Had a heating element that was open, so it wasn't heating, but was also shorted to ground. That should trip the GFI. And that hot tub was running when I got there. That's the scary part. So I went over, pressed the test button on the GFI. GFI was bad. So immediately contacted the homeowner who wasn't home, contacted other people in the household, went down into the basement, shut off the main breaker feeding it, and instructed everybody that was in the house and also the homeowner, you need a licensed electrician to come out here and replace this defective breaker immediately before we can go any further. So it's a rare occurrence, but it happens. What's inside these GFIs is a little electronic circuit, and that electronic circuit can get zapped by power surges, lightning strikes, or sometimes they just die of old age. But anyways, what I was saying about this thing is that it's running so smooth and not vibrating. I really don't even think I want to mess with that pulley. So I mean, there's a slight amount of vibration in there, but I mean, it's just walking on the table the slightest amount. See how I can push this with my finger and move it around? It's because it's walking on the table a tiny bit. See, if I had this bolted down to the table, it would transfer the vibration into the tabletop. That's why it gets louder when I do that. It's interesting when this slows down, the centrifugal switch kicks in and it suddenly just goes brrr. See it? I've never seen one do that before. It's almost like a brake mechanism in that motor. That's weird.